In this video, we are going to work on solving polynomial equations and also see their connections to x-intercepts on graphs. Our first method that we're going to use to solve equations is factoring. So hopefully you've seen lots of factoring or done lots of factoring practice up until this point, but this is just a little reminder about the steps that we should take when we are solving. The first thing we want to do is factor out the GCF. That just makes the rest of our factoring easier. Once that GCF has been factored out, we're going to factor whatever is remaining, probably a quadratic. And then the next step is to set each factor equal to 0. And that's because of something called the zero product property, meaning that if something multiplies to an answer of 0, then at least one of those things had to be 0. And then lastly, we'll take each of those equations now that they're equal to 0, and we will solve for x. So let's jump into a problem. This problem from Delta Math, thanks Delta Math, is asking us to solve algebraically for all values of x. So this word algebraically, right, has that hidden word of algebra in it. Really what that means is that we're not allowed to use graphs to answer this question. That's going to be one of our other methods. So algebraically, I would say that's a hint that we should be trying to solve things with factoring. So let's try that now. So our first step was to factor out the GCF. So like, what would the GCF be here? X to the 5th, 8x to the 4th, and 12x cubed. What do they all have in common? Well, they all have a variable of x, but our GCF is not just x. Right, for greatest common factor, the G stands for greatest there. We want to factor out as many of these x's as we can. Right here, this x cubed, that means that we have 3 x's being multiplied. Each of these has at least 3, so I'm going to factor out an x cubed. I also am going to look at the coefficients. Our coefficients here would be 1, 8, and 12, but there's no factor that all of these have in common except for 1. So there's nothing else that we're going to add into our GCF. So let's start by factoring out x cubed. Think of dividing each of these 3 terms by x cubed. What would get left behind? Each of these terms would leave something behind. We would have x squared left behind, right? There'd still be 2 x's here. Here we'd have 1x, but we'd also have the 8. And here, if we're factoring out x cubed, there's no more x's, but we still have a 12. Okay, so that was our step 1, factoring out the GCF. Step 2 is to factor whatever you have remaining. In this case, we still have a quadratic that remains. So let's set up our sets of parentheses here. If I want to factor x squared plus 8x plus 12, I'm going to start these binomials, right? Each of these sets of parentheses are going to get 2 terms. I'm going to start them off with x, right? That way they multiply to x squared. And here is where we try to figure out what numbers will multiply to 12, but also add up to positive 8. Hopefully you can come up with 6 and 2, right? Both of those being positive, they do the job for us. Now here's where the ZPP, the zero product property, comes in for that third step. It says set each factor equal to 0. Our first factor doesn't have parentheses around it, but it's still a factor. So I'm going to write that one down. Here's our second factor, x plus 6 equals 0. And our third factor, x plus 2 equals 0. Now we have one more thing we need to do, and that is to solve for x. So I have to solve each of these equations. May not have done this before, but we have to uncube something. That means we're going to take a cube root. But the cube root of 0 is just 0. Next one, I'm going to solve for x by subtracting by 6 on both sides. So here we get x equals negative 6. And on our last one, we'd subtract 2 on all these, and we get x equals negative 2. So my solutions are x equals 0, x equals negative 6, and x equals negative 2. Like that. Let's take a look at one more example of how we would solve by factoring. This one is partially factored for us. In fact, it's at a place where I think we could just take each of these factors and set it equal to 0. And that's because we're missing that linear term in the middle here. So I'm going to go skip. I'm skipping right to setting each factor equal to 0. So how do I know that this is factored? Look at this setup. It has a set of parentheses, no operation here, and another set of parentheses. That means that these are being multiplied. And that's what factored form is, a bunch of things being multiplied together. If we have that and it's equal to 0, it's already been factored. So we can set each factor equal to 0. Now I have to do my solving. Okay, so let's solve this equation. I would add 49 to both sides. Now I have 100x squared equals 49. And I have to divide by 100 before I take the square root there. Now I'm going to leave my answer as a fraction. Why would I do that? Well, I like the number 49 and 100 because they're perfect squares. And I know the next thing that's going to happen I want to have perfect squares for. So now to get our solution here, we want a square root. In the last problem, we were doing a cube root. Now we're doing a square root. Don't forget, with a square root, we get two solutions. We get the positive version and the negative version of that answer. So now that I have the 49 and 100, I can take the square root of the top and get 7, and the square root of the bottom and get 10. So there's two answers right there. Positive 7/10 and negative 7/10. All right, let's solve the other equation now. We have x squared minus 7 equals 0, so let's add 7 to both sides. And I have to take a square root again. Remember, we just did this. Square roots get two answers. So x equals plus or minus, square root of 7. 7's not a perfect square. That's fine. We'll just leave it inside the square root here. So our answer is plus root 7 and negative root 7. So in the end, we wound up getting 4 answers for that. Let's move on to a different method. What if we were allowed to use the graph to answer a problem? Well, what's nice is when we're solving, all we have to do is identify the x-intercepts of the graph. And it turns out that the x-intercepts are the real solutions if we were solving that equation of whatever that equation is, if it was equal to 0. Okay, so x-intercepts are solutions to equations equal to 0. So here we go. Thanks again, Delta Math. It's given us the graph of y equals f of x. What are the real solutions of f of x equals 0? Oh, this was the hint that said, the real solutions, go find those x-intercepts. So I'm going to go do that. Remember that this is the x-axis, it's labeled. Here's my first x-intercept at -8. I'm going to put commas to separate these out. Here's another x-intercept that looks like it's at -3. Another one right here at +3. And the last one here is at 6. Isn't that easy? So those x-intercepts give us the real solutions. Let's see one more of these. Same setup. We have the graph of f of x. What are the real solutions of f of x equals 0? Let's go find those x-intercepts. Here's one. Now be careful. This one's a little different. Notice that it doesn't cross through at -6 the way it crosses through at 2. Something special is happening here. We're going to come back to talk about this, but just so you know, this actually counts as 2 answers. I don't need to write it down twice, but that's going to be helpful to know in the future. So -6 and 2 would be my x-intercepts, and therefore they are my real solutions. Okay, we got one more method we need to talk about. And that's using synthetic division, but that's only because we're going to use it to help us to factor. So we are going to be dividing a polynomial by a given factor. So what that means is that someone's going to give us one of the factors, but we have to do work to find the other factor. And once we find it, then we're going to set that resulting factor equal to 0. And if it's quadratic, we're probably going to use quadratic formula, but whatever it is, we're going to solve for x. Okay, so we're going to divide to factor and then solve. All right, we have f of x equals some cubic polynomial, and x plus 7 is a factor of f of x. So there's the given factor. Find all of the zeros. This word zeros, that's another word for x-intercepts, which we know is another word for solutions, right? So we need to find all of the solutions for this one. So here we go. We are going to use our synthetic division. I'm going to put a -7 in the box. How did I know to put a -7 in the box? That's the value that makes x plus 7 equal to 0. Next, I'm going to use the coefficients from my cubic. So that's going to be 1, 1, -37, and positive 35. So that setup is the most important thing, right? Because if we mess this up, then everything else is going to be wrong. Now it told us that x plus 7 is a factor. So we expect to get a 0 here for the remainder. Let's see if that happens. First thing we do is bring down the 1, and then we start our multiplying. So 1 times -7, -7, and then we add down. And I'm going to repeat that process. So -6 times -7 is positive 42. Add down and we get positive 5. 5 times -7 is -35. And perfect, 35 and -35 add up to 0. All right, so we got what we were supposed to get. But remember, this is what we were really looking for. This is telling me that there is a factor of x squared minus 6x plus 5. Remember that this is the remainder. And then if we go from right to left, this is constant, linear, quadratic, and we could go up from there if we want. Here's our other factor. If I go back to my directions here, it said set the resulting factor equal to 0. Okay, I can do that. So I can solve this now. If it's a quadratic, I could use quadratic formula, but if it's factorable, I could also choose to factor. And let's see here, is this one factorable? Let's give it a try, right? We could put x's here, and then what numbers would multiply to 5? 5 and 1, but I need them to add up to -6. So what if we made them both negative? That's perfect. They multiply to positive 5, they add up to -6. I got a winner here. So we would set each factor equal to 0 and solve for x. So I get x equals 5 and x equals 1. Don't forget, we also have another answer from up here. X also equals -7 because x plus 7 was one of the factors. So we wound up getting these two answers from doing our work. But really this was code for one of the answers as well. So -7, 5, and 1. Let's take a look at one more. This is a different way that Delta Math might tell you about a factor. That's right here. It's using that remainder theorem notation, right? Where it's saying, look, we plugged in -4 and got 0. That's the same thing as saying that x plus 4 is a factor, and that -4 is a solution, right? So either way, we look at that. That's really helpful. So I'm just going to write that down right now. X equals -4. Boom, one of our answers. Now let's use that -4 to do some synthetic division to find out what are the other solutions. So I'm putting that -4 in the box to start off our synthetic division. Now I'm going to find our coefficients. We'd have 1, 5, -2, and -24. Here we go. Bring down the 1. Multiply. Add. Again, multiply. Add. And one more time, multiply. and add. Perfect. We got a remainder of 0 like we were supposed to. Okay. This is what we're looking for, though. This is telling me that x squared plus x minus 6 is a factor, and I'm going to set that equal to 0 and solve. This, I believe, is factorable. Let's try this. What numbers will multiply to negative 6? We would need a positive and a negative to do that. And we could work with 3 and 2, and then that way they'd also add up to 1. Awesome. And I set each factor equal to 0. And then I solve. I get negative 3. Over here, I get 2. Put that together with the one from the beginning, and there's 3 answers. So here's something else that we haven't mentioned, but notice the degree of the original function over here. See how that's 3? That actually tells you how many solutions you're supposed to have. So here, I'm not surprised that I have 3 answers. Look, I'm going to go backwards now. 3. We had 3 solutions. Look at this one. If we multiplied this out, we would have degree 4, which makes sense why we have 4 solutions. This one's the weirdest one. This one says we're supposed to have 5 solutions. And that's because some weird stuff was happening with the 0 here. Okay? This actually counts for more than that. This is something we're going to come back to when we get into graphing. But for now, it's a good thing to check how many answers you have. And you always want to see if you're missing some. All right, good luck with your practice.